All right, guys, so we're going to get into chapter 6, which is all about chemical bonding. So we have the periodic table of elements, but most things around us are not just pure one element. It's more than one element chemically bonded together to make compounds. So we're going to look at different types of bonds. Today we're going to look at ionic bonding. So that's going to be between a metal and non-metal and what's going to hold them together. So we'll get into this. So first off, noble gases, what do you know about them? So think about where are noble gases located, what are some characteristics about them. Give you a second there. You should come up with that they are located all the way in the 18th row here, all the way to the side, and we know they are completely unreactive. Well, if we understand why they're completely unreactive, that's going to help us with ionic bonding. So they're completely unreactive because their full outer energy level, their outermost energy level is completely full. So that's what's going to get into this chemical bonding. So if they have a filled energy level, we're going to say that, you can say that they're stable, or lack of a better word, you could say like they're happy. They're not going to react. So because they're stable and happy, filled outer energy level, they're going to be less likely to react. So noble gases are pure elements. They don't bond with other things because they already have that outer energy level completely filled. So to kind of look at this, we're going to look at electron dot diagrams. So these things are a piece of cake to draw here. All right, basically there's two steps. First step, you're going to, or what is an electron dot diagram? It's going to be a model that just shows us the number of valence electrons, because then we're going to use those valence electrons to do the ionic bonding. So step one, you're going to write the atomic symbol, and then step two, you just place the dots around it to show the number of valence electrons. So again, those are the two steps. So we're going to get some practice doing those two steps. All right, so if we look at aluminum, all right, so you can go, if you were writing this, you would write the atomic symbol, which is the 1 or 2 letter symbol there. Find aluminum on your periodic table. So we know that it's in group 13. So again, this is in the answer key section. You can use this periodic table. We see it's in group 13, and every element in group 13 has 3 valence electrons. So all we have to do is put 3 dots around aluminum. Now it doesn't matter where you put the dots, all right? I wouldn't put any more than 2 on one side though. So I could have put 2 over here, I could have put 1 on top instead of on bottom, I could put 1 here, 1 there, 1 there. It doesn't matter as long as you have the correct number of dots. So potassium, you find the K on here, so that's the atomic symbol. It's in group 1, so it must have 1 valence electron. If we go to chlorine, it's number 17 atomic number, so you can find it. It's in group 17, so it has 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7, and its outermost energy level. Sulfur, atomic number 16. So it's found in group 16, so it's going to have 6 valence electrons. So it's very easy. You just got to look at what group it's in, and that tells you the number of valence electrons. So there's practice there. So a couple things. An atom that gains 1 or more electrons will have what type of charge? Again, if it takes in more electrons, we know electrons are positive or negative. They're going to be negative, so if we take in more electrons, it's going to have a negative charge. An atom that loses 1 or more electrons. So if I get rid of electrons, now I have more protons than electrons, I'm going to have a positive charge. So these positive charges, these are going to be your metals on the left side of the periodic table. And the negative, those are going to be the non-metals. So an atom that gains or loses one or more electrons, that's just a general term for an ion. Just reviewing that, it's an atom with a charge. A positive ion is called a cation, and a negative ion is called an anion. Easy way to remember this. All right, cation, if you look at it, it is C, A, like you see A, that T, it kind of looks like a positive sign, right? So C, a positive ion. So it's basically telling you the answer there. If you see a positive ion, well, that's a cation, that's going to be a positive ion. Then you just remember anion has to be the opposite. All right, so this chart's going to help us out. So we're going to kind of fill in this chart here. I'll help you through two, and then you can fill in the rest, and we'll check your answers here. So chlorine, atomic symbol, Cl. Total number of electrons, you find that by looking at the atomic number. So it has 17 protons, so it's going to start with 17 electrons. Number of valence electrons, we talked about, it's in group 17. So it's going to have 7 valence electrons. Now, for the number of electrons gained or lost, they want to get to a full outer energy level. So they always want to get to either 0 or 8. This is called the octet rule. 0 or 8 electrons, that's what it wants to get to, valence electrons. So in this case, 7, it's closer to 8, so it's going to gain 1 more electron. Now if it gains an additional electron, we know electrons are negatively charged, so the charge of the ion is going to be -1. So that's what we're really looking for. What ion is this going to form? And this is the steps to get there. All right, potassium. Find it on your periodic table, K. So you should get it as atomic number 19, so it's going to start with 19 electrons. Valence electrons, what group is it in? It's in group 1, so it's going to have 1 valence electron, so it's going to lose 1 electron. Because again, it's going to 0, 8, which one's closer? 0, it has to get rid of that 1, so in this case, it's going to form a positive 1. Now if I had like 3 electrons and I lose 3 electrons, this would be a positive 3. So the number of electrons gained or lost is going to tell you that number. So I want you to pause the video, take some time to do the rest of them. Be careful with hydrogen and carbon. All right, these can actually form a positive or a negative ion. Hydrogen, only has 1 energy level, and remember that energy level only can hold 2 electrons. So in this case, this is the one exception. Hydrogen, it kind of wants to get to 0 or 2 valence electrons. All right, pause this. Go fill in the chart, then you can check your answers. All right, once you have it filled out, again, you can pause this to check your answers here. Make sure that you're getting the correct number of valence electrons. Gained or losing electrons, getting to that 0 or 8, the magic number there. And then based on that, so if you're gaining electrons, it should always be a negative number. If you're losing electrons, it should always be a positive ion. So pause this, check your answers before we move on. All right, a couple things here. What is an ionic bond? So ionic bond, atoms will transfer 1 or more what? What are we changing? We're either gaining or losing. We should get electrons. All right, that's going to give us the positive and negative charge. And that positive and that negative, we know they attract, so that's what's going to hold these 2 ions together to make a compound. So each atom is left with a full outer shell or energy level there. So an ionic bond always forms between a metal ion that has a positive charge and a non-metal with a negative charge here. So it's always a metal and non-metal because metals are going to be positive. and nonmetals are going to be negative, and that's what's going to attract them together to hold that ionic bond. So let's try to show this a little bit now. So we'll do two together here. So if we have sodium, I'm going to start. First step is to draw the electron dot diagram. Sodium, again, look on the periodic table. Its atomic number is 11, so it's found in group 1, so it's going to have 1 valence electron. Now here we have chlorine, so I'm going to write the electron dot diagram here. So the atomic symbol, it's found in group 17, so it's going to have 7 valence electrons. Now if I look at this, sodium wants to get to 0, chlorine wants to get to 8. Well, I can do that, make both of them happy by drawing an arrow saying this electron is going to go over to that chlorine atom. Now when that happens, what would the charge be on the sodium? It got rid of 1 electron, so it is going to be a positive 1. This chlorine atom, it gained an electron, so its charge is going to be negative 1. So you always have to make sure your positive and negative charges balance out. That's how you know you're done with this problem. So if I were to write this chemical formula, I just need 1 atom of sodium for every 1 atom of chlorine. It's a 1-to-1 ratio. All right, so I don't need any subscripts here. So this is sodium chloride, better known as table salt there. So a couple things, electron dot diagrams, show the arrow transfer of electrons, show me the charge, and then you should be able to come up with the chemical formula. So let's try another one. We have magnesium. So Mg, it's in group 2, find it on the periodic table. So it's going to have 2 valence electrons. Now iodine. Iodine should be found in group 17, so we know 7 valence electrons. So right here, I have the electron dot diagram. So this electron from the magnesium is going to go over to the iodine to make it 8. Now what about this guy over here? He can't go over there because that already has 8, so it's happy it's not going to take in any more electrons. So what we need to do is we need to draw another iodine atom. So again, this iodine atom is going to have 7 valence electrons. So this one also needs 1. Well, that's perfect because that's where this other electron from the magnesium can go. So now look at the charges here. This magnesium got rid of 2 electrons, so it's going to be a positive 2. This iodine atom took in 1 electron, so it's a negative 1. This one took in 1 electron as well, so negative 1. So I have positive 2. I have a total of negative 2 here because each one's negative 1 and there's 2 atoms of it. So if I go to write this formula, my formula is going to be Mg, then I, and we're going to put a subscript 2. So this 2, this subscript tells us we need 2 iodine atoms for every 1 magnesium atom. So if your subscript is 1, you only need 1 atom, you don't even have to write it. But if it's anything other than 1, if it's a 2, 3, or 4, you need to write the subscript there to tell you how many atoms. So magnesium iodide always forms at this ratio, 1 magnesium to 2 iodine atoms. Now that doesn't mean you just have a total of 3 atoms. It could be you have 50 magnesium atoms. Well, then that would mean you have to have 100 iodine atoms, so twice as many. So that's ionic bonding. So hopefully you can use this to get some practice doing some examples here. I'll do, let's see if there's, I'll do maybe one more example here. So oxygen and sodium. So this is just slightly different. If you feel comfortable, you can move, you can stop here and if you feel like you can do these types of problems. I'll do one more. Let's say for sodium has 1 valence electron because it's in group 1, and oxygen in group 16, so it has 6 valence electrons. All right? We know this one's gonna come over. Now that only makes 1, 2, 3, 4, 5, 6, 7. So it's not happy yet, so that's where we need to add another sodium atom. So if we add another sodium atom, now this oxygen has 1, 2, 3, 4, 5, 6, 7, 8. So it's happy. Both of these sodiums got rid of their electrons, so they went down to 0. Again, our charges, this would be +1, +1. This is -2. So overall we have +2, -2, it cancels out, we're good. The chemical formula, Na, we need our subscript 2, and then we have 1 atom of oxygen. All right, that's ionic bonding. If you have questions, send me an email.